Hello and welcome to SudoKanard. I found some sort of Kakuro by digging in the archives of Logic Masters Deutschland. I found a puzzle by Richard Stolk. Well, that wasn't really difficult to find a puzzle by Richard Stolk, but I dug until 2009, more than 10 years ago, more than 11 years ago, actually. And this is called Jigsaw Sudokakuro, and it basically combines the rules of regular Kakuro and Jigsaw Sudoku, which is also called irregular Sudoku or even scattered Sudoku, because this set of 9 yellow cells is a whole region, meaning that those 9 yellow cells should contain all digits from 1 to 9 exactly once, and so should every column, every row, and every outlined region. And the yellow region is an outlined region as well. And for the rest, it's regular Kakuro rules. And obviously, on each row and each column, all digits should sum to 45, which is the sum of all digits from 1 to 9. And this is something that we can check. Yeah, well, 45 already. 31 plus 14 is 45. 15 plus 15 plus 15, that's 45. Okay. Now this puzzle in 11 years has been solved 143 times, which makes 13 times per year, but I guess it was solved much more times in the old days than recently. It has a rating of 90%, that's the rating in terms of satisfaction, and the difficulty level, which should be somewhat reliable, is of 3 stars out of 5, which makes it somewhat difficult but not insurmountable. Okay, let's start. Where shall I begin? Are there any constrained sums? Not that much, not that many. Ooh. It seems to be tricky. Should there be some arithmetics like in Kira Sudoku? Well, that would be spicy, but I don't see how I could do that. I could pull up such a trick. Oh, well, first thing I notice is something of irregular Sudoku. When you have an irregular region such as this one, you have all digits from 1 to 9, but all those 5 digits are common, are shared by this column and this region. So those 5 digits are obviously not in here, and they are also not in here. So the 5 digits that are here should be the same as those ones. But I'm not sure it's that helpful. Mm-hmm. Wow. Oh, here there's 16. I almost missed this one. So these digits should be 7 and 9. But this 25 is not that restricted. If this is a 9, then those have to be 1, 2, 3, 4, and 6. But if it's a 7, then I have to do 18 with all 5 remaining cells, and there are 2 possibilities. So 3 possibilities on the whole And those possibilities just correspond to those here. The compositions for 20 are 983, 974, which is ruled out by the fact that one of those digits should be here. So I can't put both 9 and 7 in here. So I can rule out this one. 9, 6, 5, 8, 6, and 5. So if I put a 1, then I've only got this one here. And if I put a 7, then it's one of those. Oh, here there's some cool arithmetics. Just, I know that those 9 cells add up to 45, and this is, and those 8 digits add up to 37, so this is an 8. First digit. And I can do something similar in here. Those 9 digits here form a whole region, so they must add up to 45, 10, 23, 38, so this is a 7. So now these 3 digits must add up to 11 without using 8 or 7. So there are 6, 4, 1, 6, 3, and 2, and that's it. And so I know there's a 6 in one of those yellow cells, and it rules out 6 from all other yellow cells because they form a full region. And so this can't be a 6. It can still be 7, 8, or 9, paired with 8, 7, or 6. Perhaps I shouldn't notate all of those candidates right now, but I've done it. Okay, all right. I don't think there's anything similar in here. There's almost something similar. I know in some killer Sudokus, you're supposed to sum a whole bunch of regions, but it seems too early to resort to such crude tricks. That's not crude, actually. That's very sophisticated. Oh, but I think I can rule out 6, 3, and 2. Because if I put 6, 3, and 2 in here, then the remaining digits on the row are 1, 9, and 5. And then this 8 sum becomes impossible. I can't choose 2 digits from those 3 digits to add up to 8. So those digits can't be 6, 2, and 3. They must be 1, 4, and 6. Fine logic. Well, what else would you expect from Richard? Not sure how to pronounce his name with a Dutch accent. Well, now all big digits are taken except 9, so 9 must be in this 11, it can't be in this 8 sum, so these are 2 and 9, and the 8 sum is 3 plus 5. That's a start. And 1, 4, and 6 are all excluded from the other yellow cells. So this is not a 4 nor a 6, but there are still other possibilities. Where should I look? Where could there be some similar? Oh, here! Oh. Really? Oh, yes. These 6 digits add up to 35. And they're a part of this region, whose sum is 45. So those 3 digits should add up to 10. And this can't be an 8. Because the remaining 2 digits would have a sum of 2, which is not possible. So these must be now 1 and 2 and 7, or 1 and 3 and 6. There's a 9 somewhere in there, which is paired with this 9, so we know there's no other 9 in here, but that's not so useful. And oh, something similar is happening here. Those 6 digits have a sum of 29, so these 3 digits have a sum of 16, which is really not helpful. There are plenty of decompositions for 16 as a sum of 3 different digits. The fact that 3 and 5 are not allowed in, it's a sum of 4 digits. They're not allowed in these cells, but one of them could be in this cell, which doesn't help at all. These 2 digits have a sum of 8 without using 7. So there are 2 possibilities, 2 and 6, 3 and 5. But those horizontal sums are not so constrained. Not sure what to do. Oh, so there's a 9 somewhere, but 9 couldn't be in a 14 sum. It could be here, and this 13 paired with a 4. Here it would be with a 4. And so the remaining digits would not be 2 and 4, they would be 1 and 5. And because of the 1 in here, oh no. No. If I try to put a 9 in here, then I have a 4 here. And so 4 is not available for a sum of 2 digits making 6. And 1 is not available either. Oh, and anyway, 4 has been excluded for this 20 sum. So 9 can't go here. So 9 cannot go here, there, or there. But 9 can still go in one of those cells, or in this one. But if I put 9 in here, no, it can't go there, because once again I need 2 digits adding up to 6. 1 is not available, so they have to be 2 and 4, and only 4 is enough for a 13 sum, but it needs another 9. So 9 is not in the bottom row, so 9 has to be in one of those cells. And this fixes the 7-9 pair. And now this 9 gives us this 8 and this 7, and so these digits must be 1 and 2. And we already have 5 cells, 5 yellow cells. The remaining 4 yellow cells must be 2, 3, 5, and 7. Those can't be 2 and 7, so they have to be 3 or 5. And actually, I pencil mark this one as the opposite of this one. So we know there are 2 scenarios, the left one and the right one. And is right correct? That's another issue. Okay, so this 20 clue uses 9 after all, so it's not this one. And the remaining digits must be either 8 or 3, or 8 and 3, or 6 and 5. Well, what would remain for this 15 clue? The remaining digits in the first case are 5, 6, and 4, 5, and 6. And there are 2 possibilities for this. Oh no, 8 can't go in this 13 sum. So actually only 9 and 4 are possible. Now for this 9, 6, 5, the remaining digits are 3, 8, and 4. And there again, 8 plus 4, 5 is impossible for this 13 sum because of this 8. So the only possibility is 9 plus 4 in both cases. And now 9 and 4 must be somewhere in this column, but they can't be here because 9 and 4 are in this region. So 9 and 4 have to be up there. And down there we have 6 and 8, which may be distributed in 2 fashions, as we've seen. So 2 scenarios again, 6 and 8 with 5 and 3, or 8 and 6 with 3 and 5. Okay, that's nice, I think, because now we have a 3-5 pair, which makes a sum of 8, and those digits must have a sum of 6, and 5 is not available, so they have to be 2 and 4 in some order. Oh, and I do some alignment with 1 and 2 here, because they are a sort of X-wing on 2s. And here we have a 5 or 7, according to which digits we place in here. And what do we see? 8 is not in those cells. 8 has to be somewhere around here. Well, doesn't seem to be really something to ponder. Oh, now this 2-4 pair is interesting in relation to this 16 clue. We need another 8 without using 7 and without using 2, so they have to be 3 and 5. And this 3-5 pair removes the possibility of this 5. That's a 7, that's a 2, that's a 4. And now the Sudoku rule means this is a 1, this is a 2. Those remaining digits must be 9, 6, and 1. And somehow those digits should add up to 15. And I think there's only one way, because we need to get an odd sum, and this is an odd number. So the sum of the other two digits must be even, so they need to have the same parity, so they can't include a 6. And this has to be a 6. For 6, this is a 5. And that's what? Oh, sorry. That's the other way around. This is a 3, this is a 5. And it matches the 1-9 pair. Well, and this 1-9 pair doesn't seem to be resolved now. Oh, and now, on this row we need a 2, because there's no 2 in those digits, but this 2-9 pair in this region rules out 2 from those cells, so 2 must be in this yellow cell, and it fixes the 2-9 pair. And those digits now must be 2, 3, 4, and 6. Beautiful logic once again. The remaining digits in this region are 1, 5, 7, and 8. 1, 7, this is 5 or 8. And I write them all down here. Up there we need 1, 2, 4, 6. Well, doesn't seem to be really useful, but then I could be mistaken. And this digit must be somewhere around here. Oh, and this 9 is not there. It's not there, so it has to go here. There's a 9 in one of those cells, and the other digit is this same digit, which is not here, which is not here. So the possibilities are 5, 8, 9, and one of them is a 9, and 1 and 7 are here together with the missing digit of this 5, 8. Let's have a look at the yellow region. We have a 2 here, so we still need 3, 5, and 7. And 7 can't go in this cell, so 7 must be here. And that's a 4. And we have 5 or 3 in this cell, paired with 4 or 6. This is so intricate. I really love how Sudoku logic, how irregular Sudoku logic and Kakuro logic and Kakuro arithmetics obviously are so intertwined. That's really, really nice. This 7 says there's a 7 in one of those cells. Not sure that Snyder notation is really something useful in this context. In this context, I mean. Now let's recall this, what some people call the law of leftovers, which is what I explained earlier, that those 4 digits had to be the same as those 4 digits. There's the same in here by symmetry. Those 4 digits are the missing, are not those 5 digits, are totally different from those 5 digits, and it's the same for those 4 digits, so they must be the same. So 9 and 2 must be somewhere in this area. And 2 is not here, so 2 has to go in one of those cells. But we could still have 9 and 1 in here. Actually, I couldn't have 1 in here, because 1 here would need 7 and 9 here. So I would have a repeated 9 in this region. So 9 can't be here, so 9 has to go there. That's a 2-9 pair. And if I try to put 9 on top, then those 2 digits would have a sum of 3, which would make them 1 and 2, and I would have a repeated 2. So that's 2 on the top and 9 at the bottom. What about this 10 sum? Looks like I've broken the puzzle, which is really, really sad if that's the case, because this sum of 2 digits can't be 1 plus 9, it can't be 2 plus 8, it can't be 7 plus 3, it can't be 4 plus 6, so it can't be anything. Where was I wrong? Oh, no, well, let's have another look. Now, what I ruled out was this, but I didn't rule out this. And actually, I think I've just proved that this is the correct solution, because I just proved that 9 can't go here, because if I have a 2-9 pair here, this 10 sum can't be done. And what I thought was just me breaking the puzzle is just that proving that 9 can't go here, so 9 has to go there, and the only possibility is that. And now 2 can't go in this cell because it would require a repeated 9 in here, so 2 must be down there, and this 17 sum is fulfilled by a 6, and this 6 fixes this. That's a 4 downstairs and a 5 upstairs, and this 5 now, by teleportation, gives us this 3 by, well, that's by I don't know by what, but that's really something. Okay, that's good progress. And those 4 digits must be the same as those, so this one must go there, and it pushes this 7 here. So this digit must be the one that's not here, 8 or 5. And this digit must go up there, 5 or 8. And now, to complete this sum to 12, just 5 is ruled out by this 5, but the sum of 12 would require 6, a repeated 6, so this 5 is ruled out for 2 reasons. So that's an 8, that's a 3 here, and 5 and 7 in those cells, and an 8 downstairs, a 5 here, 5 is removed from those cells, And that's some progress again. Let's have a look at those cells. They must add up to 7 without using the 2. There are still 2 possibilities, 1 and 6. Oh no, 7 is ruled out, so... Oh, sorry, 7. 7 has no business in a 2-cell sum of 7. So it can be 1 and 6 or 3 and 4. 3 can't go there because it would bring a 7 in the same area of this 7 as this 7. What should I do next? Nine. In this row, 9 can't go here. 9 can't go here because of this 8-9 pair. It can't go there, so 9 has to be here. The remaining digits are 3, 5, 4, and 6. 5 can't be here, so that's 3, 5, or 6. 3, 4, 6, sorry, there must be a 5 in there. Oh, 5 and 4 excluded are already in this column, so this has to be 3 or 6. And 6 looks somewhat unlikely, but not impossible for this sum of 18. And there's a 5 somewhere in one of those cells. Where is 7 in this region? Not here, not here, not here, not here, so 7 is here. No interaction with those. Oh, but this 18 sum, I need another 11 without using 7 or 5. There are still 9 plus 2, 8 plus 3. So the counterpart of this 8, 9 and this column is somewhere up there. And there's no 1. 1 is not among those digits, so 1 has to be in one of those cells. Which make this 6 somewhat likely in the end. Well, in this column, in this 28 sum, we already have 16. We need 12. And 8 and 2 are excluded. Oh, yes, I know this. These add up to 7. That's true. Well, if there are 3 and 4, then this must be a 6, and those must be 1 and 5. Well, I know nothing about this actually. Oh, is there anything I can do? Oh yes, there's something I can do with this 13, because I still need to place a 4 in this column, and this 4 rules out 4 from this cell, these cells, so 4 must be here. And now for some more arithmetics. That's 18. Those digits must be 1, 2, and 6. Oh, this is a 1. That's a naked single, actually. Those must be 2 and 6. So that's 9, 13, 31. So those digits have a sum of 14. without using the 6, that's 5 and 9. So now we have both 5s on those rows, both 9s. And we know that's not a 9, that's a 1, that's a 9, that's not a 1. Oh, and that's not a 6 either, because of this 6. So, no. So those two yellow cells now are a 1-6 pair. And now to complete the 16, this is 6 or 1. Which means that this 7 sum can't be 6 plus 1 because there's one of the digits in here. So they have to be 3 and 4. So that's a 6. That's not a 6. That's not a 6. And those must be 1 and 5. So now this one can't be in the same region as this 1-5 pair, so it must be on the upper on the upper cell, giving us a 5, a 1, and this 5 has a very nice effect in here. That's a 3 on top, with together with the 8, the 6, and the 5. I put this one in the center. I still need an 8 in this column, and I now know that it's not here, it has to be there. Those digits to complete this row must be 2 and 3. And I don't know in which order yet. But this 8 in clue should help us disambiguate that. If I put a 6 in here, that's 7. And I can still make 11. But this 3 is not enough. 3 would make this a 1, this a 2, and this would have to be a 12. So this is not a 3, that's a 6, that's not a 6. And this column needs a 6, so 6 has to go there. And those digits now must be 2 and 4. Yes. And these 3 digits must be 3, 4, and 5 in some order. But, well, I must have 2 because 3 plus 4 plus 5 is 12, so there must be a 2 in here. Well, anyway, there had to be a 2 somewhere. But there has to be a 5 because 2 plus 3 plus 5, well, the only way is 2 plus 4 plus 5, so that's 2, 4, and 5. So this is a 2, that's a 3, that's a 4, that's a 3, that's a 4, and this is a 3. How does Simon say? It's stunning. It really is. Now, I should be close to the end, I think. To complete this column, I still need 7, 8, and 3. 3, 8, so that's a 7. 3 and 8 here. Oh, I didn't check those sums. That's correct. That's correct. Oh, and to complete this 8 include, this has to be an 8 and a 9 on the left side of it. those digits are 2 and 9, but I know that both 9 on those 2 rows are already accounted for. That's called an X-wing in Sudoku, but it's just a matter of having exactly 2 9s in total on 2 rows. So now 9 can't go here, and 9 has to go there, with 2 here. This 2 gives this 6, this 2. Oh, no ripple effect here. Okay. What do I still need? 1, 6, 5, and 8. There's the same phenomenon with the 5s, which are both accounted for on those rows. So 5 in this region must be here. And this 15 sum now needs a 1. So that's a 1, that's a 6, that's a 1. And those must be 8 and 6, and because of this 6, that's 8 here and 6 here. This column needs 2, 3 and 8, 3 and 8 here. That's a 2, 3 here, so that's an 8, and a 3, which make this an 8, this a 3, this a 4, this a 3, and now this 4 makes this a 9, this a 4, that's a 5, that's a 9, that's a 7, and that's a 5. No more pairs, so I just hope the end should be a breeze. I still need 6 and 9 here because of this 9. That's 6 and 9. Here I need 5 and 7 because of this 5. That's 7 and 5. Those must be 1 and 8. With this 8, that's 1 and 8. 1, 7, 2, and 6. Yes, and yes, this makes 19. Now I'm going to enter the solution code on Logic Masters Deutschland, and I solemnly declare that this puzzle has been solved 144 times now. And it was really a beautiful puzzle. I wonder whether Richard Stolk has ever kept track of how many puzzles he has created in all those years, but so many amazing puzzles and so many different ideas. This is really brilliant. Well, this video has been very long already. Thanks for watching this video, and see you later on SudoKanard.